Hi guys, last episode of this packet, and then you should be done with all of your science packet and be able to turn it in this Friday. Episode 8. So episode 8, we're going to kind of put everything together and talk about the flow of energy, or how heat or thermal energy is transferred. So I want you to think about this. When you have a glass of ice water, the temperature of your water will never get colder than 32 degrees, no matter how much ice you add to your water. Now, we're going to watch a few videos. One video we've already watched, but this time we're going to focus on matter and energy. In your packet, you have video number 1. In that box, I want you to draw what you see right now, right? We see a glass, it's full of water, and it's outside, right? Sitting on a table or deck. So first, let's label everything that has matter. Well, the glass has matter, the air has matter around it, and the water has matter, and the table is sitting on. So all those are matter. Now, let's talk about where is the energy. All right, now writing what has energy. So the things that have energy here, right? We have the glass of water has energy, the water inside of it. The air outside, right, has energy and it has, so which of those two, let's just focus on those two. Which of those two do you think has a greater energy? Or which one do you think are the molecules moving the fastest in the liquid water or air? All right, and what I mean by greater energy here, I think of kind of the temperature. And you probably don't know, or maybe you remember from this video. So it's outside in a cold day. So our water, right, is going to have a warmer temperature than the air. So our water is going to be number 1, meaning it has the highest temperature. And the air is going to be a number 2 because our air has a cooler temperature overall. Now, as we watch the video, we see that the water changes or freezing. So what happened? So thinking about this system, what is happening is those molecules in that glass are moving pretty fast. But since it's so cold out there, those molecules are losing energy. The molecules are moving around, but as they bump into that cold air or the cold glass of it, they lose energy. And every time they do that, they're going to get slower and slower. So in this first video, our energy went from high to low energy. So again, the water in the glass, right, those molecules began to slow down more and more, causing the molecules to spread far apart and decrease their speed and then in turn freeze. Now let's look at video 2. So now go down to video number 2 box. All right, here's video number 2. So in video number 2, we have a glass. And this glass, we're going to fill it up with some ice and some water. And we're going to place the glass in a really warm area. So again, draw this in your video 2 box. And then now we're going to make a list. So on our list, we're going to make a list of what has matter. Well, here, right, everything has matter. We have a glass. We have ice, we have water, we have the air, and again, remember it's warm air, And I think that's everything that has matter. Now let's talk about the heat energy, or kind of temperature. Which one is going to have the warmest temperature, right? It'll be air first, right? The warm air that we have. And then we're going to have the water. We'll have the second, right? Will be the second warmest. And then our ice is going to be the third. Now, let's see what happens. So here we add our water. And kind of let's see what happens. So here, here they're showing you 100% humidity, meaning it's a hot. All right, here. So now we have a whole bunch of the water outside of the glass. Well, here, right, the air had the most energy because it was really warm air. So the air had the highest temperature, we'll say. Awesome. So the air molecules would hit that glass, and that glass is filled with cold water, ice cold water. So as the air hits the glass, those air molecules slow down and lose a lot of energy because the glass is really cold. As those molecules hit the glass and those air molecules slow down, then they attract to the other air molecules, causing the moisture in the air, or those water molecules, to condense or to gather together and form water. The ice in the glass, remember the water, right, had a higher temperature than the ice. The water would hit those ice molecules, causing them, those molecules in the water, to receive more energy. So from these two observations, we have discovered that energy moves from an area of higher to lower, or always from warmer to cooler temperatures. Now, at the very bottom, it says, use your model to explain how either adding or removing energy affects matter. So think about what is causing the water to freeze or the water to condense on the glass, right? So the water to freeze. So that cold air outside, right, is removing the energy from the water in the glass. The molecules of the glass are slowing down because that cool air is removing the energy. The energy is going from the inside the glass out to the air. And then when it's condensing, right, the energy from the air is being transferred, is losing energy as it hits that glass, and the air molecules are slowing down and condensing. So when you add or remove energy, right, it's going to affect matter. And energy always goes from high to low. So energy always will flow from high energy to low energy. So down at the very bottom, it says, use your model to explain how adding or removing energy affects matter. Well, here's a great model of that you could draw. So here, as we increase energy, right, as we add energy, it's going to cause the molecules to move faster, thus changing the state of matter. It is. As we decrease energy, or as we slow down those molecules, we are going to change the state of matter. So it will change from a gas to a liquid as we slow the molecules down or decrease the amount of energy. If we keep decreasing the amount of energy, then that liquid's going to turn to a solid. So this is a diagram you can draw on that last box. And that is everything for episode 8. The last 2 pages in your science packet where it says atoms and molecules, if you want to play 20 questions with someone in your family, it's kind of a fun game. You just read the directions on there, and then you pick an atom or a molecule. On that page are a list of some molecules, and if you want to pick an atom, that's the page before it, the periodic table of elements. So you're going to pick one, and you can write it down somewhere. You can write it in your packet, but you don't want the person who's guessing to see what it is. And then they can only ask you yes or no questions to try and figure out which you picked. So for example, if I picked the atom hydrogen, I would write down hydrogen on my paper. And you were trying to guess, you could only ask me yes or no questions. So you could ask me, is it an atom? And I could say yes. And you could say, does the atom have less than 5 protons? Remember, that's the atomic number. And I would say yes. And then you would look at your periodic table. That game is completely optional. You don't have to play the game if you want. It's just kind of a fun thing that we do. Tomorrow, we'll watch a video from Bill Nye, one of our favorite science guys, unwrapping up this whole unit for us. Next week, we will have a quiz on this unit. So we'll talk to you guys later. Bye.